So one of the things that you can do to help yourself with this graph is to think, okay, if I start with this first one, I am going to make some white space right above so we can draw a tiny little graph of what's happening. That too is a horizontal compression by a factor of a half. We might also remind ourselves that we've got this formula that says our period is 2 pi over our b value. And the b value in the first one is 2, means that our period is going to be 2 pi over 2, which simplifies to pi. If our period is pi, and I draw a quick picture, I would mark where pi is, divide it into 4 equal sections. So that'll give me pi over 2, pi over 4, 3 pi over 4. Amplitude is 1, so it goes up to 1 and down to -1. Sine graph starts in the middle going up. So I draw a tiny little graph there just to see or visualize a little bit of what's going on. From that, you can see that your period is pi, your amplitude's 1, the graph continues on forever, so your domain is everything. Your range is -1 to 1, and your phase shift is 0 because we haven't moved it left or right. Now, our zeros are at 0, pi over 2, pi, 3 pi over 2. So I'm just listing them right now. But I want to also think about, because one of the things that we did at the beginning is we looked at our regular sine graph right? Here is our parent graph, our regular sine graph. And one of the things when we first looked at our regular sine graph was we noticed that all the zeros were k pi, where k was an element of the integers. So how are we going to write the zeros for this? Well, what's happened? All of our x values are multiplied by 1/2. The same thing's going to apply to your zeros. If you multiply all of your zeros by 1/2, we can write all of our zeros as k pi over 2, where k is an element of the integers. If we look at our list, can you see that when k is 0, we have that one? When k is 1, we'd have 1 pi over 2. When k is 2, you would have 2 pi over 2. Can you see that that's pi? Then 3 pi over 2, then 4 pi over 2, then 5 pi over 2, and so on. And so we can use the idea that our x values are multiplied by 1/2 and take that we know what the zeros of our regular sine graph are and multiply them by 1/2 as well. Because that horizontal compression is going to affect all of your x values and going to affect all of your zeros as well. So for the second one, what's happened now? We've got a new amplitude. That 1/2 in front is a vertical compression by 1/2. But the a value affects your amplitude, and so now our amplitude, which was 1, is now 1/2. Our period is still pi. Domain is still everything. Does it make sense that when you multiply by 1/2, your range is now from -1/2 to 1/2? No phase shift, and again, our zeros are still the same. Next thing we do is we add a phase shift. The period is still pi, because we still have a 2 here. Amplitude is still 1/2. Domain is still everything. The range is still from -1/2 to 1/2. But now we have a phase shift of pi over 4 to the right. So what is that going to do to our zeros? Our zeros were k pi over 2, but now we've moved things pi over 4 to the right, so we can just add pi over 4 to all of them, where k is an integer. So first our zeros got multiplied by a half, and now we've added pi over 4 to them. And finally, in this one, our center line, or our sinusoidal axis, is at -3. And so our whole graph has been vertically translated 3 units down. Does that affect my period? No. Your period is always 2 pi over your b value, and your b value is still 2, so your period is going to be still pi. Your amplitude is always your a value, always positive, because your amplitude is your distance from your center line to a maximum, and that's always your a value. It's still a half. Domain is still everything. But now our range, and if you wrote it as negative 3.5 to negative 2.5, that's fine. Because we've moved it down 3, it was from a negative a half to a half, now moved down 3. It's from negative 3.5 to negative 2.5. We still have a phase of pi over 4. I actually wouldn't mind if you wrote the word right there. The fact that it's a positive pi over 4 implies that it's to the right.
Does it matter if you write it as a mixed fraction or?
No, if you wrote it as negative 3.5, that way is fine too. And what happens when you move it down? Where are your new x-intercepts? Well, now there's none. Because it got moved down, your range doesn't even include any x-intercepts. So one of the things that you're going to be expected to do, quite often the final exam really likes this question, is they're going to ask you to graph this equation with all 4 transformations. Interestingly, in the transformation unit on the final exam, they rarely have more than 3 transformations at a time. But in the sinusoidals unit, they almost always have all 4. And the reason they have all 4 is because we can apply our knowledge about what each of these things mean and our knowledge of a sine graph and how it works to graph them quickly. Now, at the top of your next page, you have a fair bit of space at the top of the next page. And so, at the top of the page there, you can write this as a title. It works for sine and cos. And I call it dab C. I call it dab C because the D stands for the D value, the A stands for the A value, the B stands for the B value, and the C stands for the C value, and the dash stands for a dashed line that we do in between. And also the dash is there because debk doesn't flow as nice as dab C. So dab C says you start with your D. The very first thing you're going to do is draw your sinusoidal axis, and your sinusoidal axis is always y equals your D value. Then your A stands for your amplitude, and you're going to use your amplitude. Remember, amplitude is the distance from the center line to a maximum and from the center line to the minimum, you're going to use your amplitude to label your max and min values on your y-axis. Dab. You're going to use your b value to find your period. Remember that your period is equal to 2 pi divided by your b value. Label one period on your x-axis and divide into 4 equal sections. The dash stands for a dotted line. Draw your graph without the phase shift. With a dotted line. Because it's not your final graph. Here, big dash. So we are going to, after doing the dab, yes, we are going to draw our graph with a dotted line before we do our phase shift, and finally your C value, which is your phase shift, apply the horizontal translation. So at the bottom of the page, we're going to graph the graph that we just looked at in the previous example. The previous example said graph, well, looked at y equals 1/2 sine 2 x minus pi over 4 minus 3. Here's your a value, your b value, your c value, your d value. So when trying to graph this, instead of using what you did in transformations, where you did all your horizontal stretches and compressions first, then your translations, and took a whole bunch of points from your parent graph and transformed them, the shortcut allows us to do this a lot faster. What we do is we start by drawing our sinusoidal axis. Our d value is -3. So we go to 1, 2, 3, -3. Dotted line for your sinusoidal axis. If you have a red pen, even better. Label it. Y equals 3 is your center line. Just off to the side, I'm going to write dab C and put a check mark above the D because that's the first part. Next, A is your amplitude. You use your amplitude to mark your max value and your min value on your y-axis. So our amplitude is 1/2. That means we go up 1/2 to -2.5 and down 1/2 to -3.5. Those will be our max and min values. We have just completed the A part. Off to the side, we use, in B, we use our B value to find our period. So our formula says our period is 2 pi divided by our B value, 2 pi over 2 is equal to pi. So we go on our x-axis, we mark one period at pi and divide it into 4 equal sections. Half of pi would be pi over 2. Half of pi over 2 would be pi over 4. 1 pi over 4, 2 pi over 4, 3 pi over 4. We have now done the b value. The next is the dash. This is where you draw your sine graph without the translation, without the phase shift. So sine graph starts in the middle. So there's our center line. At the first ticking mark, it would be at a maximum, then back to the middle, then to the minimum, then back to the middle. And we draw this with the dotted line because this is not our final graph. This is just our graph without the phase shift. We have now done the dash. Finally, we apply the horizontal translation. This one has been moved pi over 4 to the right. I'm going to draw my final graph in black. That means I take this point and I move it pi over 4 to the right. I take this point, move it pi over 4 to the right, pi over 4 to the right, pi over 4 to the right, pi over 4 to the right. And here is our final graph.